Okay, this next question is a real thinker. We've got parallelogram WXYZ, and it has an area of 9 square units with vertices shown. And we need to figure out the value of A and the value of B. Okay, well, we have our answers given there. But let's see how we go about doing that. First of all, let's set up WX, Y, and Z. Wx is going to be equal to the vector 4, 2, a plus 9. We know that because Wx has an x component given by 2 minus negative 2, which is 4, 5 minus 3, which is 2, and a minus negative 9, which is a plus 9. And Wz, which is right here, has an x component given by 2 minus negative 2, which is 4, 4 minus 3, which is 1, negative 6 minus negative 9, which is 3. So this vector is 4, 2, comma, a plus 9, and this vector is 4, 1, 3. Well, we know that the area of it is 9 square units. So we're going to go YZXY and YZXY. And we're going to patiently determine the cross product. 2 times 3 is 6, minus a plus 9 as a quantity is the same as 6 minus a minus 9, which is negative a minus 3. A plus 9 times 4 minus 4 times 3 simplifies to 4a plus 24. And lastly, 4 times 1 is 4, minus 2 times 4 is 8, 4 minus 8 is negative 4. So our x, y, and z components are negative a minus 3, 4a plus 24, and negative 4. That's our cross product. And so the magnitude of that cross product is the area of the parallelogram. Well, the area of the parallelogram is 9 square units. So 9 is equal to that square root right there. Alright, well, what we can do is simply square both sides. So we can say the square root of 81 is equal to the square root of this whole quantity, this whole expression. And that's determined by simply squaring negative a minus 3, squaring 4a plus 24, and squaring negative 4. And so underneath this square root symbol, we get 17a squared plus 198a plus 601. So the square root of 81 equals the square root of all this. We square both sides and we get 81 equal to 17a squared plus 198a plus 601. Now we go about our typical process of solving for a quadratic. Let one side equal 0. 0 is going to equal a plus 4 times 17a plus 130. Well, that means either this factor equals 0 or this factor equals 0. They'll both be valid. If a plus 4 equals 0, then a equals negative 4. If 17a plus 130 equals 0, then a equals negative 130 over 17. Well, those are both valid. So, suppose a equals negative 4. Suppose this is a negative 4 right there. Well, we know that Wx, which is right here, has to equal Zy, which is right here, because it's a parallelogram. So Wx has to equal Zy. Well, Wx is 2 minus negative 2, which is 4. Zy is 6 minus 2, which is 4. The x's work. The z's for Wx would be 5 minus 3, which is 2. The z's for, the y component for Zy would be 6 minus 4, which is 2. So they match up. Finally, the z component for Wx would be a minus negative 9, which is a plus 9, and the component for the z component for Zy would be b minus negative 6, which is b plus 6. So a plus 9 has to equal b plus 6. If a equals negative 4, then we're going to have a b value of negative 1 to accomplish that. And if a equals negative 130 over 17, then we're going to have a b value of negative 79 over 17 to accomplish that. So in other words, if a is negative 4, if I put a negative 4 right there, in order to make wx, with this being a negative 4, equal to zy, b has to equal negative 1. Think about it. If that's a negative 4, then negative 4 minus negative 9 is 5. If this b value right here is a negative 1, then negative 6 minus negative 1 is also negative 5. So it would work. On the other hand, if a is negative 130 over 17, the arithmetic is a little more difficult, but if a is negative 130 over 17, then in order for wx to equal zy, negative 130 over 17 minus negative 9 will have to equal b plus 6. And setting that up and doing some relatively simple fractions arithmetic would mean that the b value, to make that happen, has to be negative 79 over 17. And so we see that either a is negative 4 and b is negative 1, or a is negative 130 over 17 and b is negative 79 over 17.